Hi, everybody. Today we're doing sections 1.4 and 1.5 in our human geography class. So let's go ahead and get started. I will try and make this short, but it's a decent chunk of material. So we're going to start today talking about location. All right, and then so that's unit 1.4. And then we'll go to human environment interaction, which is 1.5. And so this is a little more definition heavy than the last little bit, but let's go ahead and get started. So here's the content that what we're going to be looking at. So the essential knowledge down here, spatial concepts include absolute and relative location. You should be familiar with that. Space and how we define that. Place, flows, distance, decay, time, space, compression, and pattern. So hopefully within about 15 or 20 minutes, these terms will make more sense to you. Alrighty, and so let's just review real quick because we already did absolute and relative location, but let's do it one more time. So when we talk about location, there are these two different types. And so absolute location is physically where you are on Earth, all right? And so we would use GPS to figure out somebody's absolute location. It doesn't matter what's around. It is what are the coordinates of where you're at, you know? And so let me see if I can get my thing working here. Sorry. And so, you know, if we're using the longitude latitude coordinates, that's mostly how we would measure absolute location today. All right, and GPS would do it. And so relative location, again, the word relative means in relation to other things. So if you see relative location or relative distance, relative, whatever, it is in terms of something else. And so relative location would be, are you north of a certain place or are you east of a certain place? You're about, 200 miles from a place. And so, again, with respect to like University High School, the Grand Canyon is 345 miles north of University High School. I'm sorry, yeah, Grand Canyon is north of University High School. It is, University High is 1,300 miles southeast of Seattle. And so you get the idea. So it's all relative to other things. All right, so a couple of definitions for you. So you probably want to pause this screen at some point just so you can get all the definitions down. So when we talk about place, it is simply place refers to the specific human and physical characteristics of a location. And so you can see this is a picture over here of Tucson. And so can you think of different human characteristics or physical characteristics of Tucson that would help define the place? All right, and so with human characteristics, we would look at things like language, religion, income, demographics, education, economic stuff as well. And so that's part of the place of Tucson. And then we look at physical characteristics. All right, what's the climate like? Are there mountains? Are there rivers? Is it desert? I mean, some of these things describe Tucson. And so the type of rainfall, how much rainfall, I guess. And so those are the broad definitions of place, human and physical characteristics of a place. And so if you can think in your head, how would you describe Tucson to somebody else? That's describing place. All right. Then we also have this thing called a sense of place. All right. And so this is kind of in quotes. So when you have a sense of a place, it's what your perception is of that place. All right. And so I'll use myself as an example. When I lived on the East Coast, I lived in South Carolina and Georgia. When I lived on the East Coast and I heard about Tucson, the only thing that came to my head were cactus and hot desert. That was it. That was my sense of a place. When I got out here, I realized clearly there's a lot more of it. And so my perception of Tucson changed dramatically once I was here. It's still cactus and hot desert, but there's so much more to it. All right. You can also look at it if I went to San Francisco and you went to San Francisco and 3 other people went to San Francisco, are we all going to describe San Francisco in the same way? All right, because we'll all be attracted to one thing or another of a certain place, but we could visit the exact same place and see 2 completely different things, and that's fine. That's what happens. But that's when you see this phrase "sense of place." That's what it's talking about. Just your perceptions, and your perceptions are all your own. We all have our own individual perceptions. All right, and so, whoops, sorry about that. And so when we get to region, so this is one more, and we're going to do a lot more about regions the next unit or the next lesson. A region is simply a group of places in the same area that share some type of characteristics. And so characteristics might be language, could be type of government, could be a lot of different things. But and we'll talk about the different types of regions. And so take a second and see how you would answer these things. All right. And so yeah. All right, a couple of different ways to refer to a place. Again, here's some more definitions, and these will definitely be tested. So the term site up here is the characteristic at the type of characteristics at the immediate location. All right, and so that definition of place I just gave, if we hone it down, site is really the specific way to look at it. And so, what's the soil type? What's the labor force? Specifically, what are the characteristics of Tucson? All right. And then situation, again, this is the relational stuff. Situation is the location of a place relative to the surroundings. All right, and so relative to other areas, what is the situation of Tucson? All right, and so we would compare it to, say, Phoenix or the Grand Canyon, or to California or New Mexico or Mexico. And so that's what we mean by situation. All right, so this term toponym, it sounds a little technical, but all it is it just means a place's name. All right, the word Tucson, where's the word Tucson come from? And I looked it up, and there's some debate about it, I'll put it that way. But some names, so a toponym is any name, so Tucson is our toponym for this area. Some names are very descriptive of the place, and so you see a place like Grand Canyon. Is that descriptive of the place? Is it a Grand Canyon? Yeah. If you see something like Miami Beach, is there a beach in Miami? And the answer is yes. Take a look here. This is Death Valley. All right. And so is that descriptive of this area? And by the looks of it, you get the idea. This is Alcatraz Island. All right, we normally just refer to it as Alcatraz, but technical name, Alcatraz Island. This is an island. This is used to be a prison. If you ever get to San Francisco and get a chance to take a tour of this, it's pretty awesome. But anyway, here's the Golden Gate Bridge in the back, San Francisco off to the side. But anyway, so those are the toponyms. Some names are a little bit confusing. Iceland and Greenland, you've probably heard. Iceland is relatively green and Greenland is relatively icy. Lake City, Iowa is another name, another toponym that is not reflective of their place because there is no lake. All right, so now this other, the concept, first concept coming out of this is this thing called time-space compression. All right, and so let me just start by giving you this example. So this is like the Mayflower coming over from England to North America. And this is a concept jet. It's a supersonic jet. And so when we talk about time-space compression, if we go back to like 1500, right, the year 1500, for this ship to get from England to New York, it took 66 days, all right, so a couple of months. All right, and so today, and this is Virgin Atlantic is the company, they have this plane that if it's successful to get from London to New York, it's going to take 2 hours. All right. And so when we talk about time-space compression, this is compressing the areas on Earth through technology. All right. And this could either be through transportation technology or it could be through communication technology. All right. And so that's what we mean by time-space compression. How quickly can we get from one place to another? All righty. And so here's just kind of an interesting little chart. This is the distance and time. So if you take a look over here, this is the speed of news in miles per hour. All right. And so this would be like 1 mile an hour, 2, 3, 4. And so this is the year down here. And so up to 1800, news traveled at about 1 mile an hour. And so if there was, some big event that happened over here and these people were waiting to hear about it, and this distance was 100 miles, it would take 100 minutes. 100 hours. Sorry about that. For that news to travel. Today, we know it is instant because we can watch it watch it live. And so you can see, and this is the Industrial Revolution, by the way. They call this a hockey stick growth because it's really flat for a long time and then it just takes off. And so you can see news of the Battle of Trafalgar off the coast of Spain in 1805. It took 2.7 miles an hour. Indian Mutiny in London from Delhi, I'm sorry, 3.7. Lincoln's assassination, so in 1865, news traveled at 12 miles an hour. And again, today it's instant because we can watch it all live. All right, so that's what they mean by time-space compression. If we can ever get to this, where we can just transport, teleport, then that would shrink it even more. Imagine being able to go from London to New York in 5 seconds. Be pretty awesome. So when we talk about time-space compression, it can have an impact on all of these factors. And so remember, these are our ESPN factors. And so I want you to think a little bit about how the advancement or how time-space compression would affect those. And so I'll just give you some hints on them. So economics, we can transport materials a lot faster across the globe, globalization. Social, how might that be impacted by time-space compression? Migration could be in there. Healthcare, we can get readings a lot faster, things like that. Political, obviously, Twitter, Lord Twitter. And so we can communicate with each other on a really rapid basis. If you look at the uprisings in Egypt and other parts in that area, North Africa, in the Middle East, when those uprisings were happening, I think it was 2012 or so, they were communicating through Twitter, and they could all work together by communicating through Twitter. So anyway, I'll let you think some more about those. This is, if we were in class, this is what we would be doing. Some of the technological advances, obviously, for information, it's all about the internet. Our ability to communicate with each other is drastically different because of the internet and any other the transportation technologies. Alrighty. And so do know that this does have an effect on culture, which is our social part. The fact that we are more exposed at a quicker rate to other cultures does have an impact on us, and our culture is exposed to other people at a quicker rate, which does have an impact on them. All right, another term or concept to be familiar with is this one called spatial interaction. Spatial interaction is the contact or movement or the flow of things between locations. And so there's 2 ways for things to flow. All right, so we're talking about the flow of things, and it could be through physical connections, roads, railroads, things like that, or it could be informational connections like the television or the internet or radio or whatever it is. All right, and then the other part of this distance and connection thing is called the friction of distance. All right, and so it indicates that when things are farther apart, we tend to be less connected. All right, so this leads us into this other concept called distance decay. And I do want you to know this graph, all right, because, well, you'll see it on a test. But it does prove a point. It's a very simple graph. It has level of interaction here on the y-axis, all right, and then it's got distance over here. And so this is saying, look, if this is 0 miles and this is 100 miles, I'm just making up numbers, that's 200 miles, how much interaction is there? And so people that are extremely close have very high levels of interaction. And as that distance starts to go away, our interaction starts to lessen. And so this might be Phoenix, and this might be Flagstaff. And so think about, do we have some interactions with Phoenix? Yeah, because it's 2 hours away. Is there as much interaction with Flagstaff or Los Angeles or San Diego? The answer is no, because it's just farther away. It's not that it doesn't exist, but it's a lot less. And so this idea of distance decay, make sure you get the definition here, inverse relationship between distance and connection. So obviously, if we were sitting in class, so the distance is basically 0, and we would have a very high level of interaction. And think about this, what we're doing right now, there is distance between us, and we're still having interactions through our Zoom meetings, but it is definitely less. All right. Now we're looking at density and distribution. So density, this is a population density map over here. All right, population density. This is a dot distribution. Right? So when we talk about density, density is simply the number of something in a specific area. All right. So we're not talking about clustered or dispersed. We're just talking about the physical number of something in an area. And so population density is like that. And so, I wish this wasn't red. So if we, kind of took this in blocks and started counting density, so let's say that's block 1, 2, 3, and 4, we can start to measure off what's the density in block 1, what's the density in block 4, and all you would do is count up the dots. All right. And it is often compared to each other, so a high density area or a low density area. Obviously, a block out here is very low density. A block right here is very high density. Okay. Let's see. Also, and this one's interesting, density can be a psychological term. So if you're a big city kind of person, if you go to New York and you're like, hey, this is awesome. I love all the people. I thrive off of all this interaction. The density might not be terribly bad for you. But if you're not that type, if you would rather be in Montana, with 14 other people within 20 miles of you, then your definition of density might be a little bit different. And so, we all fall somewhere on that line. Do we like big city or nothing? And so that's the idea of psychological density. Alrighty. And so make sure you can understand the difference between density and distribution. All right. And so density just measures how much. And so let's take a look at this real quick. So let's say that these were areas of crime. All right. And so if we were to count these up, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So there's 12 there. And just to save you, there's 12 there. And let's say that 12 events happened in this one spot. All right. And so the density in these is all the same, the exact same density, 12, 12, and 12. All right. But the distribution is different. So we've talked about the distribution before, the idea of something being either clustered or dispersed. And so again, we know that clustered means kind of together. All right. Dispersed means kind of separated, like this map. And then there's this other term that I want to introduce you to, and it's called a hotspot. You've heard the phrase before, but a hotspot would be where one thing is happening multiple times, where something is happening multiple times in the same place. And so we would call this a hotspot. And if this were crime, 12 crimes being committed in this one spot would be a hotspot. Alrighty. And so think about if you're a police chief, would this be the kind of information that you would want to know? And the answer is clearly yes. That's where you figure out where your resources go. All right. And so make sure you know the difference between density, which is the actual number of things in an area, versus distribution, which is how those things are spread out in that area. And again, clustered, dispersed, and hotspot. All right. The other type of distribution that I want to talk about is this thing called township and range. And so this was invented by Thomas Jefferson, and that fact's kind of cool. And it is used it was after the Revolutionary War. I'll tell you the story real quick. After the Revolutionary War, and so we had all this land to the west, right, that we got after the Revolutionary War. And so they wanted to figure out, one of the things they wanted to do for the Revolutionary soldiers was to give them land as part of payment for their service, like a reward for their service to help liberate the country, right? And so the problem was, when you have all this land, how do you map it all out? Like, how do you make sure that you're not giving the same thing, same piece of land to two different people, or that the land's overlapping, all right? And so they had to survey. They came up with what they called a survey system for the U.S. All right, survey is not unique to this, but you get the idea. So they wanted to survey the land and figure out how to break it up. And this is called township and range, all right? And so pretty much everything west of the original 13 colonies was mapped like this. And so they use very similar to the longitude and latitude lines, all right? And so when we lay this out, and I'll show you, well, let me show you this. And so you can see this would kind of be like the grid system. This is Tucson, and we'll look at this in a second. But and so they put all the land into a grid system. And so they have a principal meridian, and that is this north-south line. It would be a longitudinal line. And they also have what they call a baseline. And each state would have different baselines and different principal meridians. And so anyway, so let's pretend that, this is Arizona. All right, let's say that this is the baseline up here, and that this is the principal meridian. You get the idea. All right, and so what they do is they break these things up into what they call townships and ranges. All right. And so the township is like measuring north and south. All right. And so this would be township north. And so we would use this line, use the baseline and say, okay, is it north or south of this line? All right. And so you can see for this one, the township, T stands for township, and that's north. And so we'd say, look, here's the baseline. And we know that this box is 3 blocks up. All right. And so that would be the township that's going this way. And then the range is going this way. And so we would say, okay, the range is 4 blocks east. And so 1, 2, 3, 4. And so it's just like an X, graphing something out. If I gave you the coordinates X equals 3 and Y equals 4, you could figure this out. Or I said that backwards, it's okay. And so anyway, and so this is how they do it. And so they break this up, and these are some details you don't need to know, but I'm just going to let you know. Each of these blocks is 6 miles. All right. And so that's 6 miles, and that's 6 miles. And so we break it up into those blocks. And so that would be the township. And so one of these blocks is 6 miles squared. All right. So 1, 2, 3, 4, 5, 6. And so that would be this. And so when you get that block, they break that up into 36 blocks. All right. And so each of these is a square mile. So that's a mile. There's 2 miles, 3, 4, 5, and 6. All right. And so they number them going this way, and then they flip it back around and go that way, and then back this way. And so we've got, within this township, there's 36 boxes. All right. And so let's say that there was a piece of land under this box. And so it would be box 24. So again, reading this, and this is how we still do things in mapping and surveys. This would be the address basically. And like any address, they start with specifics and then go to the general, like your name, your street number, the city, the state, zip code. And so it's easiest to read this backwards. And so it would be the ranges 4 east, that's over here. The township is 3 north, that's up here. And so now we've identified the box. And so within this box, which section are we in? And so this is section 24. And again, these are still a square mile. And so they take these boxes and they break them up into quarters like this. And so now we'd say this is the northwest quarter. So that's up here. All right. And then they break that up into quarters like they did here. And then if we wanted to identify this area of land, so we're in the northwest corner, and then of this big box of the mile of the section, and then we are in the northeast block of this little box. All right. And so that's how they mapped it out. All right. And so if they're giving somebody land, they would say, okay, look, you get the northwest box of section 20. All right, which would be this. So this is your land. Congratulations. And so that's how they did it. And so if you look, something like Tucson, the way that this is mapped out, Tucson is it's a grid, really. And so you can see here's Fort Lowell Road up there. And so each of these is a mile. And so I don't know if you ever knew that, between Grant and Speedway is a mile, Speedway to Broadway is a mile, Broadway to 22nd down here is a mile. And so then we've got a mile here. So there's a mile, there's a mile, there's a mile. And so if we were to apply this grid system, we could look at it like this. And so each of, this would be a township, because this would be a section. And so then this section could be split up, and then that gets split up again. Let's just do it here. And so if you lived in this area, that's how you could figure out your address. All right. So anyway, it's this grid system that's been used to plot out and survey the U.S., and it has been used in other areas. But so you hear this phrase, township and range. It is this grid system. All right. And that was a lengthy explanation for something that you don't need to know as much detail about. So types of distribution. So we do have different types of distribution. One is linear, obviously in a line. Towns that go along a railroad line would be considered that. A circular distribution is if we have a central place here, and then the distribution flows like that. All right, and we'll look at an example there in just a second. Geometric would be some type of pattern. So squares formed by the roads, that would be, if they followed that township and range. And then just random, where do the pet owners live? And so let's look at a couple examples real quick. So linear distribution, and this isn't a straight line, but you get the idea. This would be a railroad, and when the railroads come through, that's where the towns start popping up. All right, and so that would be a decent example of a linear distribution. It follows the line. It's not straight line, but you get the idea. A circular distribution. So think about this. This is Walmart, and so you can see this is Speedway and Kolb. All right, and so think about where the people come from to shop there. All right, so we can start drawing circles around this. And so we would say, look, if people shop at Walmart, if they live in this circle, definitely. And so how far out, that's a poor circle, does this go if you're this Walmart? You know, terrible. And so, let me draw one a little bit better. And so if that's miserable. And so, you know, that's the distribution. So if you're this Walmart, where are your customers distributed? Because if it's somebody way up here, there's probably a Walmart closer, okay? Costco, any store would have this. And so that would be a circular distribution. So you can kind of see it over here, same idea. Very high distribution here. You might pick up some people coming to this point here, but at some point, nobody shows up. All right, geometric, we just did that one. Again, this is a geometric pattern. All right, and so if things were distributed geometrically. And then random was the other one. All right, last little bit for this section. So spatial association. When you start mapping things out, you start to see that, hey, some things seem to line up. And so when we do that, those things may line up because one causes the other or because there's just an association between the two. And so let me see if I can focus in on this real quick. So take a look at this map on the left. This is healthcare, U.S. hospital beds in the U.S. All right, so the purple is the hospital beds. Lost my pointer. So the purple is the hospital beds. So that's here. And then the orange here is the population distribution. And so is there an association between the number of hospital beds and the population? And so the clear answer is yes. All right, we don't see a lot of hospitals out here because there's no population. So there's definitely an association there. Can we say from this map that one thing causes the other? That answer is no, but we can definitely say they're associated. If we go over here, this is baseball stadiums. So Major League Baseball stadiums compared to the senior population, and I just put the Earth, good one. I just put the U.S. All right, and so here's the population. So is there an association between, in the red, the American League up here is hard to see, but is there an association between where these stadiums are located and the senior population? And the answer is yes. All right, but does that mean that because seniors live there, that's caused the baseball stadiums to be built? And that answer is probably no. This is just, baseball stadiums are built where lots of people are, and there just happen to be lots of seniors in those where lots of people are. And so just because, again, there's this association doesn't mean it's causal. If you think back to the John Snow map, that was causal. We saw that association between the water faucet and the people who are getting cholera. All right, and so it's something to be careful of. Association does not mean causation. Correlation and causation. All righty, so I'm going to stop it here. I'm just going to do one section here, and then I'll post the other one. So I hope you guys have a good day, and hope you guys were able to get all the notes out of this.